Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with John Redmond from Broadcom, who's going to talk today about increasing complexity in design and how power fits into this whole sphere. So one of the problems that we're starting to wrestle with now is increasing density. And in your space, which is heavily in the mobile space and some of the consumer electronics, that's becoming a real problem. How are you dealing with it?
In our consumer electronics, the power densities are becoming ever increasing. We're starting to adopt a lot of the power management, power architectures that were used and pioneered in the cell phone, where they had very aggressive power requirements due to the battery limitation. We're starting to transfer those over into other devices such as set-top box. As you know, set-top box, although it's plugged into the wall, the cost of a thermal solution and the cost of electricity is now a major concern. So we're putting power islands, dynamic power reduction, energy proportional system. These type of design techniques are now transferring to set-top box.
As a matter of fact, the Natural Resources Defense Council issued an entire report on set-top boxes, right, where they were consuming so much power that they became a cause célèbre for them. Can we actually get it down to the point where these things aren't spinning in the background all the time?
Yeah, I mean, NRDC did a great job of highlighting some of the power problems with set-top boxes. One of the biggest issues at night when you're not using it, their set-top box is on. This is being addressed in Energy Star and a voluntary agreement between the manufacturers. So this is being addressed. So we're in the process of doing that, and from architecture design standpoint, that problem is pretty much being solved. We're now starting to work on more of the active use cases and when you're actually using the set-top box and how are we going to decrease the power then.
You know, we've always got the trade-offs of power, performance, and area/cost. How do we get the cost down on those if we're starting to add all this complexity into what was traditionally a fairly simple device?
Well, that's the question of the day, Ed. We, as a set-top manufacturer, and frankly any SoC company, has to somehow monetize their technology. So the question for us that we have a tough time with is, in order to reduce the power, it's going to cost something. It's either going to cost performance or cost area, which is money. We do have a cost function internally that we use to trade off, but is that aggressive enough to meet our power targets? That's the question.
Is performance really something that you worry about in a set-top box? Is it, and if so, where is it? Because what we see is you're basically streaming stuff through the set-top box and you're communicating with the whoever the cable provider is or the satellite provider.
Yeah, I mean, the performance is ever increasing. We want to decode, encode more streams as we go from HD to 4K. Obviously that's a lot more processing that has to occur. So the requirements on a set-top box, the performance requirements are, for the foreseeable future, increasing and will continue to increase at the same clip.
So what happens on the design of the chips that are in there? Is that moving to the most advanced nodes like the mobile market? Is it sitting back at some of the older nodes?
The cost of the lower nodes is an issue. And set-top box, we are constrained by cost. And in order to be competitive, it appears right now that sticking back on the older nodes for now makes sense.
Define older nodes. Where are
28 nanometer. Right now, it makes sense to stay at 28 nanometers in our market based on the fab costs. But eventually, as history has always shown, the price of the next node will come down. I don't know when that'll be, but it will, I promise you that. Also, another big driver to go to the next node, the reason people are going to the next node is for power. I mean, the power is better at 16. The dynamic power is much better, and leakage power is also better. So there is definitely, from a power standpoint, a good motivation to go to the next node. Now, is it worth the cost? Does it justify the cost to go to the next node? At this time, the answer is no.
How much of this is being driven internally by your customer base, and how much of it is being driven externally by, there's a whole environmental movement toward prevent global warming?
Yeah, that's a good question, Ed. So it's being pulled both directions. We do have, I would say, three specific directions. One is customers are demanding lower power, and they are getting pulled by both environmental concerns like NRDC and also regulatory bodies such as Energy Star. And there's also a voluntary agreement with all the set-top manufacturers to limit power.
And so when you look at a set-top box maybe 5 years down the road, what's going to be different about it?
Obviously, there will be some changes in your set-top box, as we migrate to 4K and beyond, and we'll integrate other connectivity such as Wi-Fi, Bluetooth, Zigbee. These things are happening today on our set-top box, so that will continue to happen. But I feel the biggest change in the set-top box market is that your energy bill will go down. So that's good news for all your consumers out there. Right now, there is a lot of potential for savings of energy in the set-top box. It's not easy, but we're moving in that direction, and it'll take us a little while to realize it. And in fact, it'll take time for us to put the hooks into hardware, have the software people be able to use those hooks, and eventually the box manufacturers and the end customer realize that savings. But that's definitely in the pipe.
Are you finding that all the tools and methodologies are there to make these improvements?
On the leakage side, I think there's been great strides by 1801 to solve the power island problem. The implementation and verification used to be a headache 5 years ago. Today, I consider that a solved problem. On the dynamic power side of things and the power management side of things, I think there's a lot of room left. There's a suite of tools at the gate level, RTL level, and ESL level for power estimation and analysis, which are fairly decent, although people still struggle with the dynamic power tools because there's not an easy button. There's no push a button and the power goes down. These are analysis tools. They show you where the power is being consumed, but there's no silver bullet. You push a button, the power goes down. It's more about analyzing, changing your design, changing your architecture, changing your RTL, changing your implementation flow to push the power down. So that's one of the things that people are struggling with.
How about the expertise within a company like Broadcom to be able to take advantage of the tools effectively and really understand power? Typically, there's been one or two power guys or a handful of power guys inside a company, and that really hasn't changed a whole lot. Is that kind of knowledge being shared effectively?
That's a great question, Ed. Broadcom is absolutely pushing power into their DNA. In every design decision that we make, we want power to be part of that trade-off. One of the reasons that isn't true today is because it's hard to get the power numbers. You run a synthesis tool, you push a button, you get an area number, you get a timing number, and you make a decision. What we're trying to do is push power into that equation. So we want to make every engineer across every discipline power aware. So empower people with power.
Part of the equation also is software. Is your software team now working more closely with your hardware team, and is that externally enabled, internally enabled, externally being by tools, or is it something that still has to be done?
Well, that's the million-dollar question, Ed. How can software take advantage of all the hooks to reduce power that hardware provides? This is something we struggled with for many years, and it's still not solved. We are internally driving this in a proprietary fashion, like many other companies are doing. There is some hope in the future. IEEE 2415 is there trying to help bridge this gap between the hardware and software interface. I expect big things out of this working group, although it may take a little while for it all to take off and the tools to be there. But eventually, I think 5 years from now, there's going to be a very good solution to solve the hardware-software interface problem. And I consider it a problem today because we're losing a lot of efficiencies there.
How much of this is now dependent upon looking beyond Broadcom into your full ecosystem? So it's IP providers plus EDA tool vendors plus foundries plus your own internal groups.
Yeah, I think the path forward in reducing power, we have to lean heavily on our ecosystem partners. I know in 1801 that was a big push for us, is to align the IEEE 18010 group, our EDA vendors, our standard cell internal team, our IP internal teams, and even our external teams. Like, how do you deliver UPF? How do you deliver UPF we can use? So part of the equation for the complex power architectures is definitely working with our ecosystems partners, having everybody aligned, cutting in the right tools, techniques when everything's aligned across our vendors.
John Redmond, thank you very much for a great explanation.
You're very welcome, Ed.